Students, whatever homework is given to you, you have to submit it on the very next day between 8 am to 1 pm to the given WhatsApp number, and it is compulsory to submit your homework as your attendance will be marked on the basis of your submission.
Good morning, children. Previous lecture we have done that how can you prove that whether a number is irrational number, that means root 2, root 3 and addition of that numbers 5 plus root 2, here 3 root 2, how can you prove it as a irrational number? That proof already I explained in the previous session. Now today what we are going to see that what is the decimal expansions of a rational number. If it is a rational number, how its decimal expansion look like. For example, here I have written some of the decimal expansions and I converted it into rational number. That means 0.375. I can write it in the form of P by Q. How can you write 375 upon 1000? And I factorized both P and Q. You already know that rational numbers are in the form of P by Q, where P and Q is not equal to 0. So 375 upon 10,000. Then 375 upon 10,000 we can write as that prime factorization, we can write as that 2 cube into 5 cube. That means I have done a prime factorization of 1000 and written it as 2 cube into 5 cube. And finally 375 also I factorized and I have written it as 3 into 5 cube. 5 cube will be cancelled. So you got that 3 by 2 cube. Clear? Now consider the next example. Second example, 0.104 upon 1000. Again, because you know that how to convert the decimal expansion into rational number. Dividing by 1000, then it will come 104 by 1000. 1000 we can write as the 10 cube. 10 cube will be 2 cube into 5 cube. And here numerator, that is the 104, we can split according to prime factorization, we can learn that 13 into 2 cube. Final 2 cube and 2 cube will be cancelled. You are going to get 13 upon 5 cube. Now one more example I consider here that which was that 0.0875. So being these are 4 points before 4 places are there after the decimal. So I have divided by 10 raised to 4 and written like this way 875 upon 10 raised to 4. That means this one we are converted into rational numbers. Then 7 into 5 cube divided by 2 raised to 4 into 5 raised to 4. That means prime factorization I did it. And finally I got the answer that 7 upon 2 raised to 4 into 5. Because here 5 raised to 4 is there. Here 5 raised to 3 is there. So we can cancel 5 raised to 3 from numerator and denominator. And we are going to get only 1. 5 is in the denominator. So can you see any similarities in this type of decimal? That means when you have factorized it, can you see any kind of similarity in these rational numbers? That means 3 upon 2 cube, 13 upon 5 cube and 7 upon 2 raised to 4 into 5. That means the decimal expansions of these rational numbers, we have discovered here that, or we have come to that clue that its denominator is in the form of 2 raised to some power, 5 raised to some power, 2 raised to and 5 raised to some power. Okay, clear for you? By looking at this, considering this example, you have seen that you have got finally the expansions. That means we have done the representation of the rational numbers. When you have done that, we have we got like this way 3 upon 2 cube, 13 upon 5 cube, 7 upon 2 raised to 4 into 5. These all are the decimal expansion which terminates. Is it right? 0.375. That means after that nothing is there. 0.104 and 0.0875. From this, we can consider a theorem. Here we can conclude a theorem like this way. Let x be a rational number and whose decimal expansion terminates. That means here 375 upon 1000 is a rational number. Its decimal expansion was what? 0.375 and is terminating. Terminating means stopping. And then x can be expressed in the form of p by q. This decimal expansion of this rational number can be expressed in the form of p upon q, and that q will be p and q are co co-prime. Co-prime I already mentioned you that which will not have any other factors other than 1. And prime factorization of q, that means denominator factors are in the form of 2 raised to m into 5 raised to n. That means 2 raised to some power multiplied by 5 raised to some power n. Necessary, not necessary that both should come. Sometimes only 2 can come, sometimes only 5 can come. That both example I showed here. And otherwise both 2 and 5. M and n are condition is that non-negative integers. That means let x be a rational number and whose decimal expansions terminates, and x can be expressed in the form of p by q, where p and q are co-prime. That means p and q does not have any common factors except 1. And prime factorization of q prime factorization, that means denominators prime factors will be in the form of 2 raised to m and 5 raised to n, and m and n are non-negative integer. Now, look at the following rational numbers. Without doing the division, how can you find out that decimal expansion of this one is terminating or non-terminating? How can you find it? Here 3 by 8 is given. So we have to convert it into a decimal expansion. For that purpose, actual division method is possible. But without doing that, how can you perform its division and finding out the decimal expansion? Let us look. 3 by 8. That means 3 by, you can write as the 2q. You know that if the denominator is in the form of 10, 1000, 100, 10,000, so decimal expansion you can find out very easily. For making it as 10, you have 100 multiples of 10. We can multiply here 5 cube because 2 cube into 5 cube you can write as the 10 cube. Is it right? So we are multiplying 5 cube here in the numerator. Same time you multiply 5 cube in the denominator also. Numerator and denominator both you are multiplying with 5 cube. Then this will be changed into 375. This will be changed into 10 cube. Is it right? 2 cube into 5 cube. Which is that formula? You already know that. A raised to m into b raised to m. You can write that ab raised to power m. That means both having same power. You can take it as the common power and whether the base are different or not. Multiplication case. A raised to m into b raised to m. So we can write it as that ab raised to power m. So we have written that 375 upon 10 cube. 375 upon 1000. 10 cube means 1000. 1000 division is easy for you. So you have answered, you have got it as 0.375. Same way, next one. 13 by 125. So here also you done 13 by 5 cube. 125 prime factorization we did it as 5 cube. But we want to get either 10 cube, or 10 square, or 10 raised to 4. So here already 5 cube is there. So if you have to make it as 10 cube, but you have to multiply 2 cube in the denominator and numerator. So it will be changed into 13 into 2 cube will be changed into 104. This will be changed into how? 10 cube. So division by 1000 it is easy for you. So you have got the decimal expansion. What was that? 0.104. Same way 7 upon 80. 7 upon 80 you got that prime factorization 7 upon 2 raised to 4 into 5. But here you have to make it as that 2 raised to 4 into 5 raised to 4. That means 10 raised to 4. Then it is easy for you to convert it into decimal expansion. For that purpose 1 5 is already there. Then what should be multiplied? You should multiply by 5 cube. One more 5 cube. That 5 cube you multiplied in the numerator. So it will be changed into how? 5 raised to power 4. So that will be changed into 10 raised to power 4 and numerator will be 7 into 5 cube, it will be 875. That means 0.0875. By this we can see that this all decimal expansion, these all rational numbers decimal expansion is going to be terminated. Is it right? 0.375, 0.104, 0.0875. And here all the denominator is in the powers of 2 and 5 also. Is it right? Denominator here also 2 into 5, here also 2 into 5, here also 2 into 5. That means from these examples what you can conclude that if it is a rational number and such that prime factorization of q is in the form of, that means this q, it is in the form of 2 raised to m into 5 raised to n. Then the decimal expansion, then x has a decimal expansion which terminates. That you already seen that 3 by 8 decimal expansion is going to be terminated 0.375. That's the last. and 13 by 125 is equal to 0.104. That means this all rational numbers decimal expansion is going to be terminated when its denominator is in the form of 2 raised to m into 5 raised to n. This is another theorem we have concluded from this one. First already we have done one theorem, same theorem again it's a revision only. That means you just reverse that theorem and then we have done. There we have seen that if the decimal expansion terminates, then it will be a rational number and hence its denominator is in the form of 2 raised to m into 5 raised to n. Then that will be a rational number. Here what is telling that if it is a rational number and its denominator is in the form of 2 raised to m into 5 raised to n, so we can say that rational numbers decimal expansion always will terminate. Now let us consider this example 1/7. This is also a rational number only. And how its decimal expansion look like? I have done the long division method like this way. And I done that 0.142857. Again it is going to be repeated like 142857. That means it will be repetition. How much part is repeating, that much part you have to keep this bar sign. That you already know that. In smaller classes you have learned. So 0.142857 bar. That means here you can see that this is non-terminating. Is it right? The decimal expansion of this rational number is non-terminating, but what is that? Repeating. That means 142857, again 142857 like that. Here you can see that in the denominator, what is the term given? 7. That means q is in the form of either other than 2 and 5. You already seen that if it is in the form of 2 raised to power into 5 raised to power, then the decimal expansion will have terminating. Now, it is not in the form of that one. So, we can say that decimal expansion of that rational number will be, it will be non-terminating, but it will be repeating. Clear for you? That you can summarize in other way. That means if it is a rational number and prime factorization of q, that means this one, denominator, if it is not in the form of 2 raised to m into 5 raised to n, other than this one, any other factors are coming that, so we can say that this x, that means this p by q, this is our x, yeah, p by q, it will have a decimal expansion, and decimal expansion how it will be, which is not terminating and repeating. Here two cases you have seen that both are rational numbers only, but one case decimal expansion is going to be terminated, other case decimal expansion is not going to be non-terminating and it is going to be repeating. Both are cases for the rational number. One case you have to see that whether the denominator is in the form of 2 raised to m into 5 raised to n, and other case it will be not in that form, that means other than that some other factors will be coming. So we can say that decimal expansion will have a non-terminating and repeating part will be there. Now this is whatever we have learned, according to that we can complete the exercise 1.4. That means here some the rational numbers are given. Without doing the division, we have to find out that whether this expression is this rational expression having a terminating decimal expansion, yeah, non-terminating repeating decimal expansion. Already I mentioned you that how to find out that. We have to prime factorize the denominator and then find out that whether it is in the form of 2 raised to m into 5 raised to n. So we can say that it is terminating. If instead of that, if any other factors are coming along with the prime factorization, so it will have a non-terminating and repeating decimal expansion will be there. I have written here only 4 questions. The remaining questions you can do yourself. Question number 1, first question, 13 by 3125. So 3125 you factorized it. So you got that 5 raised to 5. That means here 2 raised to, then there is a question that the 2 raised to is not there. But 2 raised to, if it is not there, we can write as that 2 raised to 0. Is it right? 2 raised to 0 is 1. It is in the form of 2 raised to m into 5 raised to n. I already mentioned you that if it is 5 raised to, yeah, if it is 2 raised to only, yeah, 2 raised to and 5 raised to both are there. Then only the decimal expansion will have terminating. So first question, you got that answer is that terminating. This is for the first question. Second question, that means in your question exercise, question number 2. what is asked that these questions you have got that answer terminating. If it is terminating, then you should find out that what is the decimal expansion. That is a question number 2 is there. So I have completed both in one step. Clear for you children? If it is a terminating decimal expansion, you have to complete that and find out the decimal expansion. For that purpose, what I did, here I know that 13 by 5 raised to 5 is there. That means prime factorization of 3125 is 5 raised to 5. I already mentioned you that. How can you find out this prime? We have to make it as decimal expansion by making this one as a multiple of 10. So here already 5 raised to 5 is there. If I am multiplying with 2 raised to 5, so it will be 10 raised to 5. So right. So if I multiply 2 raised to 5 extra here in the denominator, have to multiply that 2 raised to 5 in the numerator also. So this one will come 10 raised to 5. 10 raised to 5 means how many zeros? After 1 you have to put 5 zeros. And numerator you have multiplied and written that 416. 2 raised to 5 means 32. 32 multiplied by 13 I did it and 416. And finally upon division, you know that how many places you have to move to the left side. You have to move 5 places. So 1, 2, 3, 4, 5 places I moved and point I have put decimal point I have put it here. So you got the decimal expansion like this way. Clear for you? That means first and second question I correlated and did it in the first step. And second question is also 17 upon 8. That means 17 upon 2 cube. So here also 5 raised to power is not there. Then also we can say that it has a terminating decimal expansion. Now if it is a terminating decimal expansion, how can you find out the decimal expansion without doing the long division? So what will you take? You will do the denominator in the form of 10 raised to power. For that purpose 2 cube is already there. So you have to multiply by what? 5 cube. That means I multiplied numerator and denominator by 5 cube, which will become as 10 cube. So right? Then 10 cube is 1000. This one I multiplied 17 multiplied by 5 cube means 125. So we got as 2125. 2125 divided by 1000 is equal to 2.1. So here you are seeing that if they are terminating, we are going to get a decimal expansion which is terminates. Is it right? Now 64 upon 455. Here also 64 upon this one I have prime factorized, so I got 3 factors which are there 5, 7, 3, 13. So I already mentioned you that if you are getting instead of 2 and 5, any other factors if it is coming, so it will have, how it will be non-terminating, repeating decimal expansion is there. That is no need to find out. If it is terminates, then only you have to find out. That is a question. Now, look at it. Question number 4, 15 upon 1600. 15 upon 1600 you will write as that 3 into 5. And 1600 you will factorize and write as that 2 raised to 6 into 5 square. So right? Prime factorization. This 5 and 5 cancelled, so you got as that only 1 5. But for making it as 5 raised to 6, you have to multiply how much? 5 raised to 5. And that 5 raised to 5 here also, it will come 3 into 5 raised to 5 and 2 raised to 6 into 5 raised to 6. It will come 9375 upon this match. Therefore, after completion of this one, you have to move the point towards the left by 6 points. 6 places, 1, 2, 3, 4, 5, 6, then you have to. Then that means here it is a terminating decimal expansion. Why it is so? Because denominator is in the power of 2 raised to m into 5 raised to n. Therefore terminating, and that terminating expansion you already find out how about it does. Now in these sums you already learned that how can you find out a rational number is a terminating if it is in the form of denominator is in the form of 2 raised to m into 5 raised to n. If it is terminating, then how to find out that terminating decimal expansion without doing the long division. Same way, if it is not in that form, so we can say that that rational number is having non-terminating, repeating decimal expansion will be there. X is 1.4, same question number 3. Some decimal expansions are given. You have to say that whether it is a rational number or not. So by looking at the decimal expansion, you can say that whether it is a rational number or not. How can you check? Because if it is a terminating decimal expansion, we can say that it's a rational number. If it is a repeating and non-terminating decimal expansion, you can say that it is also a rational number. Without that, non-terminating and non-recurring, non-repeating, that type of numbers are coming as irrational numbers. In the first case, it is going to be terminated. Therefore, we can say that this number is what type of number? Rational number. But here it is non-terminating, but other condition is not satisfied. What is that? Repeating. What is here? 120, 1200, 12000. That means it is non-repeating and non-recurring. That means non-terminating and non-repeating. That means we can say that it will be an irrational number. And the last question, 43.1, 2, 3, 4, 5, 6, 7, 8. Right. Here one bar is given. That means this point is this part is again going to be repeated. So here what you can say that this is also a rational number, because we have seen that rational number is having terminating, either terminating or non-terminating and repeating decimal expansions. In this case also it will be rational number. And one more question is given with that. What you can say about P and Q in this, Q about in these cases. Here you can say that Q is in the form of 2 raised to m into 5 raised to n. Here also Q is in the form of 2 raised to m into 5 raised to n. In this case, it will not be like that. So you can say about this or now you might have cleared about this topic clearly now. Now we can complete this exercise. That means the homework. Up to this exercise 1.4, how many questions are left? I have done in the first question also 4 questions only. The remaining questions also you have to do as homework. And all the questions are clearly detailed given here in this class. Here today we completed that lesson, which was the chapter real numbers, and we discussed everything in detail. Now you have to do the homework related to this chapter. 4 exercises are there. All exercises you have to complete and submit in your respective subject teacher. In the very next day you have to complete and submit it. Okay. Thank you, children.